A few years ago, Tesla didn't just build better electric cars, it reinvented the way they were made. The revolution wasn't about sleek designs or futuristic interiors, it was about something far more fundamental: the battery. Tesla introduced the structural battery pack, a radical idea where the battery wasn't just a power source, but part of the car's actual frame. It made EVs lighter, stronger, and more efficient than ever before. That single innovation forced the entire auto industry to rethink how electric cars should be built. Now, a new challenger has entered the race. An American company called 24M Technologies claims they found a way to go even further, a breakthrough so big they believe their new battery design could power an electric car for 1,000 miles or 1,600 kilometers on a single charge. It sounds almost impossible, but how exactly does it work, and could it really change everything again? Let's break it down. When Tesla unveiled its structural battery pack, it was a true game changer. Before that, electric vehicles relied on bulky, inefficient designs, battery cells stored inside modules, and those modules packed into large casings. Most of that structure wasn't doing anything useful. It didn't store energy, it just held things together. Tesla flipped that idea on its head. Instead of hiding the battery inside the frame, they made the battery part of the frame itself, an integral part of the car's body. The result? Fewer materials, greater strength, and more space for energy cells. That meant higher efficiency, longer range, and less weight. It didn't take long for others to catch on. Chinese giants like BYD, CATL, and NIO adopted their own cell-to-pack and cell-to-body designs. Yet, even with these advances, there was still one major problem: wasted space. A surprising amount of every battery pack was still filled with parts that stored no energy at all, and that's the inefficiency 24M Technologies wants to eliminate completely. Even in the most advanced structural battery packs, much of the space is taken up by thousands of individual cells, each sealed in its own metal or plastic casing. Those casings are important. They prevent short circuits and overheating, but they don't actually store energy. They're safety wrappers, not power sources. To 24M, that's an enormous opportunity. If you can remove the dead weight, you can unleash the battery's true potential. According to 24M Technologies, only 30 to 60% of a traditional battery pack's volume actually stores energy. The rest is wasted space filled with structural components and safety materials that don't power the car. This means a lot of potential energy remains unused. Even though engineers have made great progress in improving energy density and charging speed, the overall design hasn't changed much for years. To truly leap forward, something more radical was needed: a complete redesign of how a battery pack is built from the ground up. That's where 24M comes in. Instead of thinking about batteries as lots of small cylinders or pouches inside a box, they've designed something entirely new. Their idea removes the cell casings altogether and integrates the energy-storing parts directly into the battery pack itself. 24M Technologies, based in Massachusetts, has developed a concept they call Electrode-to-Pack, or ETOP. It's a fresh way of thinking about energy storage. In simple terms, ETOP removes the middle layers. No separate battery cells, no modules, no heavy casing. Instead, it takes the core components that actually store energy, the anode and cathode, and builds them straight into the pack structure. The electrodes are sealed and arranged directly within the battery housing, becoming part of the system itself. This means there are no wasted materials like metal shells or plastic containers. Every bit of space can be filled with energy-storing material. According to 24M, this design could make up to 80% of the pack's volume active compared to only 30 to 60% in current batteries. That's a massive jump in efficiency, potentially doubling the energy density. That's why 24M believes a 1,000-mile range is possible using this approach. A compact, lightweight battery with high energy density could finally make electric flight practical. Still, 24M admits their biggest goal is automotive use. Cars demand high energy, fast charging, and long lifespan. And this design could meet those needs while lowering costs per kilowatt hour. In short, it could be the innovation the American EV industry desperately needs to stay competitive. As exciting as it sounds, 24M's concept isn't ready for mass production yet. One of the biggest hurdles is manufacturing scale. The global battery supply chain is currently built around familiar designs, like cylindrical, prismatic, or pouch cells. Entire factories, supply chains, and quality control systems depend on these shapes and processes. Switching to an electrode-to-pack method would mean redesigning everything from production lines to safety testing, and that could cost billions of dollars. Manufacturers would need strong proof that this new system is worth the investment. Another major concern is repair and maintenance. Traditional battery packs can isolate damaged cells without affecting the whole system. If one cell fails, technicians can replace that module, but in 24M's fully integrated design, there are no separate cells or modules. So, what happens if part of the pack fails? If one section malfunctions, could it take down the entire battery? Would mechanics need to replace the whole thing? That's still unclear, and it's one of the most serious practical concerns for real-world use. The success of this technology will depend on a collaborative effort across the industry. Automakers, battery manufacturers, and material suppliers will need to align their roadmaps and investments to support this new manufacturing paradigm. Standardization of processes and safety protocols will be crucial to build confidence and facilitate widespread adoption. Furthermore, the recycling ecosystem for such integrated packs must be developed in parallel. Without easy disassembly, new methods for recovering valuable materials like lithium, cobalt, and nickel from these solid electrode blocks must be pioneered to ensure the sustainability promise of electric vehicles is fully realized. Despite these challenges, the potential benefits, longer range, higher density, and lower cost, make this technology just too promising to ignore. When you first hear 1,000-mile range, it sounds unrealistic, but technically it's possible. Remember, 24M isn't changing the chemistry. They're just using the space better. If they can fit twice as much active material in the same size pack, they can roughly double the range. The company claims this approach could work with existing lithium-ion materials, meaning automakers wouldn't need entirely new raw materials or supply chains. That's a huge advantage. Still, proving this in real cars will take time. Battery technology is one of the toughest fields to commercialize. Many companies show promising lab results but fail to scale. Mass production requires years of testing, safety validation, and real-world trials. 24M has been developing advanced lithium-ion designs since 2010, and they're known for practical step-by-step innovation that gives their claims more credibility than startups promising magic solid-state solutions. If 24M can demonstrate consistent safety, efficiency, and recyclability, their electrode-to-pack batteries could completely redefine how electric vehicles are built. It might not happen overnight, but this could be the next big step in the electric revolution. You know, just like Tesla's structural battery once was, innovation in batteries has always driven progress in electric vehicles. Tesla's structural pack showed how integration could unlock more power and range. Now, 24M's electrode-to-pack design aims to push those limits even further, eliminating waste, reducing cost, and potentially giving electric vehicles an incredible 1,000-mile range. But challenges remain. Scaling up production, ensuring safety, and creating repairable systems are no small tasks. Still, even if the full 1,000 miles isn't achieved immediately, any improvement in energy density is a huge win for the industry. This new direction could reshape how electric cars and even aircraft are built in the future. If 24M's idea works at scale, it won't just extend range, it could redefine what's possible for sustainable transportation worldwide. The next evolution in battery design may have already begun quietly inside a Massachusetts lab.